Our solar system is a place of wonder, filled with celestial objects that spark our curiosity. From the blazing sun at its center to the icy comets that traverse its outer reaches, every component plays a unique role in the cosmic dance. Among these objects, planetary rings stand out as some of the most captivating and awe-inspiring. These rings are not just visually stunning, they are also scientifically intriguing, offering a wealth of information about the planets they encircle. Imagine a thin, disc-like structure composed of countless particles ranging in size from tiny grains to enormous boulders, all gracefully orbiting a planet. These particles can be made of ice, rock, and dust, each contributing to the ring's overall appearance and behavior. These are planetary rings, and they offer a glimpse into the dynamic and often chaotic processes that shape our universe. The interactions between ring particles can lead to collisions, clumping, and even the formation of new structures within the rings. Planetary rings are not merely beautiful ornaments. They are cosmic laboratories that provide invaluable insights into the formation and evolution of planetary systems. By observing these rings, scientists can learn about the conditions that existed in the early solar system. By studying the composition, structure, and dynamics of these rings, scientists can piece together the history of our solar system and gain a deeper understanding of the forces that govern the cosmos. This research can reveal how planets and their moons formed and evolved over billions of years. The study of planetary rings has already yielded remarkable discoveries. For instance, the intricate patterns and gaps within Saturn's rings have provided clues about the gravitational influences of its moons. From the unexpected complexity of Saturn's rings to the faint rings encircling Jupiter, each new finding expands our knowledge of the universe and challenges our preconceived notions about the nature of planetary systems. The differences between the rings of various planets also highlight the diversity of processes that can occur in different environments. As we delve deeper into the realm of planetary rings, we can expect even more astonishing revelations in the years to come. Future missions and advanced technologies will allow us to explore these rings in greater detail, uncovering secrets that have been hidden for eons. The journey of discovery is far from over, and the mysteries of planetary rings continue to inspire and captivate us. When we think of planetary rings, the image of Saturn immediately comes to mind, with its iconic and mesmerizing rings. This gas giant, the second largest planet in our solar system, is renowned for its stunning ring system, a celestial spectacle that has captivated astronomers for centuries. But what exactly are these rings made of, and what gives them their distinctive appearance that we find so fascinating? Saturn's rings are not solid structures as they may appear from a distance, but rather intricate collections of particles. Instead, they are composed of countless individual particles, each one orbiting the planet independently in a delicate dance. These particles vary greatly in size, ranging from tiny ice grains just a few micrometers across to massive chunks of ice and rock several meters in diameter. The vast majority of these particles are made of water ice, which gives Saturn's rings their characteristic bright appearance, shimmering in the sunlight. However, the rings also contain traces of rocky material, likely remnants of comets, asteroids, or even shattered moons that ventured too close to Saturn's gravitational grasp. These rocky fragments, often coated in ice, contribute to the subtle color variations observed within the rings, adding to their beauty. The origin of Saturn's rings has been a subject of intense debate and speculation among astronomers for centuries. These rings, which are one of the most iconic features of our solar system, have fascinated scientists and stargazers alike. How did such a vast and intricate system of rings come to be? The sheer scale and complexity of Saturn's rings have led to numerous theories and hypotheses over the years. While the definitive answer remains elusive, several compelling theories have emerged, each backed by scientific observations and models. Each theory offers a plausible explanation for the birth of this celestial spectacle, adding to our understanding of planetary ring systems. One prevailing theory suggests that the rings are the remnants of a shattered moon. This idea has gained traction due to the composition and distribution of the ring particles. According to this hypothesis, a moon orbiting Saturn strayed too close to the planet, possibly due to gravitational perturbations or orbital decay. Crossing a critical threshold known as the Roche limit, the Moon found itself in a region where Saturn's tidal forces became overwhelmingly strong. Within this limit, the tidal forces exerted by Saturn's gravity would have overwhelmed the Moon's own gravitational integrity, causing it to disintegrate into countless fragments. Tearing it apart into countless fragments, these pieces would then be caught in Saturn's gravitational embrace. These fragments, now caught in Saturn's gravitational embrace, would have eventually spread out into the rings we observe today. Over time, collisions and gravitational interactions would have shaped them into the thin, flat rings we see. Another compelling theory proposes that the rings formed alongside Saturn itself, from the same primordial cloud of gas and dust that gave birth to our solar system. This theory suggests that the material destined to become Saturn's rings was prevented from coalescing into a moon due to the planet's powerful gravitational influence. This theory suggests that the material destined to become Saturn's rings was prevented from coalescing into a moon due to the planet's powerful gravitational influence. Instead, this material remained trapped in orbit, gradually evolving into the rings we see today. This primordial material, influenced by Saturn's gravity, could have formed a disk around the planet, which over millions of years evolved into the rings. This theory suggests that the material destined to become Saturn's rings was prevented from coalescing into a moon due to the planet's powerful gravitational influence. Instead, this material remained trapped in orbit, gradually evolving into the rings we see today. The process would have involved countless collisions and gravitational interactions, shaping the material into the thin, flat rings we observe. The mystery of Saturn's rings continues to captivate scientists, and ongoing research may one day provide a definitive answer. For now, these theories offer fascinating glimpses into the possible origins of one of the most beautiful and enigmatic features of our solar system. Section 4. A symphony of motion, the ever-changing face of Saturn's rings. Saturn's rings are not static, unchanging structures. They are a dynamic and ever-evolving system that captivates scientists and stargazers alike. Unlike the solid rings of a planet like Uranus, Saturn's rings are composed of countless individual particles, ranging in size from tiny grains of dust to massive chunks of ice and rock. These particles are in a constant state of flux, influenced by a myriad of forces that shape their behavior and appearance. They are dynamic and constantly evolving, their appearance shaped by a complex interplay of gravitational forces, collisions, and resonances. The gravitational pull of Saturn itself, along with the influence of its many moons, creates a delicate balance that keeps the rings in place while also causing them to shift and change over time. Collisions between particles can create temporary clumps or waves that ripple through the rings, adding to their ever-changing nature. This constant dance of particles creates a mesmerizing spectacle, with the rings exhibiting subtle variations in brightness, density, and even shape over time. These variations can be influenced by factors such as the angle of sunlight hitting the rings, the presence of nearby moons, and even the gravitational pull of distant planets. The result is a breathtaking display that is never quite the same from one moment to the next. One of the most striking features of Saturn's rings is their intricate structure. What may appear as a single, solid band from a distance is actually a complex system of thousands of individual ringlets, each with its own unique characteristics. These ringlets are separated by gaps of varying widths, some of which are created by the gravitational influence of Saturn's moons. The rings are not a single uniform disk, but rather a complex system of distinct ringlets separated by gaps of varying widths. These gaps are often carved out by the gravitational influence of Saturn's moons, known as shepherd moons, which act as celestial shepherds, herding the ring particles into specific orbits. The presence of these moons can create intricate patterns within the rings, adding to their beauty and complexity. These gaps are often carved out by the gravitational influence of Saturn's moons, known as shepherd moons, which act as celestial shepherds, herding the ring particles into specific orbits. The presence of these moons can create intricate patterns within the rings, adding to their beauty and complexity. The shepherd moons play a crucial role in maintaining the structure and stability of the rings, preventing them from spreading out and dissipating over time. The particles within the rings are in constant motion, orbiting Saturn at different speeds depending on their distance from the planet. This Differential rotation creates a dynamic environment where particles are constantly interacting with one another. The closer a particle is to Saturn, the faster it orbits, while particles farther away move more slowly. This variation in orbital speed can lead to collisions and interactions that further shape the rings. This differential rotation, combined with the gravitational interactions between particles, leads to collisions that constantly reshape the rings, creating waves, clumps, and other transient features. These interactions can create temporary structures within the rings that may last for only a few hours or persist for much longer periods. The constant motion and interaction of particles ensure that the rings are always changing, adding to their allure and mystery. These dynamic processes ensure that Saturn's rings are never truly the same from one moment to the next, adding to their allure and mystery. The ever-changing nature of the rings makes them a fascinating subject of study for scientists and a source of endless wonder for anyone who gazes upon them. Whether viewed through a telescope or captured in high-resolution images, Saturn's rings continue to captivate and inspire, reminding us of the beauty and complexity of our universe. Section 5, Rings of Distinction, comparing Saturn's splendor to its celestial neighbors. While Saturn's rings are undoubtedly the most famous and impressive in our solar system, they are not alone. Jupiter, Uranus, and Neptune also possess ring systems, each with its own unique characteristics and offering valuable insights into the diversity of planetary ring formation and evolution. Jupiter's rings, unlike Saturn's icy splendor, are faint and dusty, composed primarily of small, dark particles. These rings are thought to be relatively young and constantly replenished by dust ejected from Jupiter's innermost moons. Uranus's rings, while darker and less prominent than Saturn's, are composed of larger particles and exhibit a complex structure with distinct ringlets and shepherd moons. Neptune's rings are faint and clumpy, with some regions appearing brighter than others, suggesting variations in particle density. The differences in composition, structure, and even color among these ring systems highlight the diverse processes that can lead to their formation. By studying these variations, scientists can gain a deeper understanding of the factors that influence ring evolution and the crucial role of planetary rings in the broader context of planetary system formation.